Okay, so it says, I'm scrolling down. Okay, at what rate is soda being sucked out of a cylindrical glass? So this is a cylinder that is 6 inches tall and has a radius of 2 inches. Knowing that the depth of the soda decreases at a constant rate of 0.25 inches per second. So what is this, and what are we asked to determine?
Okay. So, so we're finding, is it dr dt?
So R is a constant. R does not change. The height of liquid in the can changes because we are removing volume from it, right?
Mm-hmm.
We are removing liquid from it. Yes, so we are asked to find dV over dt at a particular instant when the rate of change of what is negative 0.25 inches per second. So this is the question.
Okay. So as the volume's changing, we want to see when it's changing at the negative 0.25.
So let's read the problem one more time. We're told to find the rate, at what rate is soda being sucked out of a cylindrical glass. So we're asked to find the volume, the rate of change of volume that is 6 inches tall. The can is 6 inches tall and has a radius of 2. Knowing that the depth of the soda decreases at a constant rate of 0.25 inches per second. So what does this represent?
I'm not sure.
Okay, so
is it something like when you know that you're looking for the change in volume when the rate is changing at negative 0.25
right.
inches
But
per
what
second?
is this rate?
No, that is like the height
Very
of the
good.
soda. Like,
The age over dt. The height of the soda is decreasing. Is this clear to everyone?
Yeah, I see what, yeah, that makes sense now.
Okay, so of course we have to start with the volume of the cylinder. And the volume of the cylinder, remember, is the area of the base times the height. But the area of the base is pi r squared times the height, which is h.
Okay.
Now, the radius is completely fixed.
Yep.
No matter what we do, the radius of the cylinder will not change. So this can be already replaced in the formula. So this is V equals 4 pi h. Because the radius is not affected. The radius is not a function of time. These two are functions of time, but not the radius. Radius is being fixed, I'm just replacing r squared by 4. So now when we differentiate, on the left-hand side we get just dv over dt. And on the right-hand side we get, can anyone help? 4 pi is 4 pi, it's a constant, I can't change that.
So it'd be 4 pi h dh over dt?
When I differentiate h, I get 1. I bring down the power and I subtract 1 from 1, right? So I get 1 multiplied by dh over dt. So if I had h squared, that would have been 2h dh over dt. But that's
Okay.
not the case. I only have h.
Gotcha.
So we are asked to determine the volume. We are given this. That's it.
So then you just plug it in.
Just plug it in. There is really nothing. So 4 times negative 0.25 is negative 1. So the answer is negative pi. But I need the measurement unit.
Would it just still be inch over, is it inch over second?
Cubic inches per second.
Very good.
Yeah. Negative pi.
Is that clear?
Yes.
Because it's the volume with respect to time. Remember, the measurement unit always comes from here. If this is volume, it has to be in cubic inches in this case. If it's area, it's going to be squared inches. And if it's just height, it's going to be inches. Very good. Good. Next question.
I had a linear approximation question, if it's okay.
Yes, please.
So it's from WebAssign. It says verify the given linear approximation at a equals 0. Then determine the values of x for which the linear approximation is accurate to within 0.1. And the function is natural log 1 plus x is approximately x.
Is that correct?
Yes.
Okay. So in order to find for what the x values, the error is less than 0.1. Was it 0.1?
Yes.
Okay, very good. So then the absolute value of the error has to be less than or equal to 0.1. So we are told that this function can be approximated by a line. Which line? This one, a linear function. So the log function can be approximated by this function, the linear function, which is just y equals x, near 0. Not anywhere else, just near 0. So then natural log 1 plus x minus x is what we have to solve for x. One more time, we're asked to find what x values make this error less than or equal to 0.1. This problem cannot be solved without a calculator, so I'm assuming that WebAssign has the calculator symbol next to it. And this will change, as we know, into negative 0.1 less than or equal to natural log of 1 plus x minus x less than or equal to 0.1. Now, I have no choice but graph this, let's say, as the first function, and then graph this as the second function, and then try to see what happens in there. Without a calculator, we can't do this. Derek, was that the symbol of calculator next to the problem?
It doesn't have any symbol, but it tells me to round my answer to 3 decimal places. So
Okay.
I just assumed that they would need one anyway.
Okay, very good. So let's go and in y equals, clear if you have anything else in there. So let's plug in this and try to find x. We don't have to graph necessarily, but the only way, we don't know Newton's method right now. So if we knew, and I can show you, but we can solve this equation very easily with Newton's method, but we don't know Newton's method. It's in chapter 4. So this is what I'm trying to solve for x. And then I'm trying to solve the other one, natural log of 1 plus x minus x plus 0.1 equals 0, and get x, whatever that is. So I will put these in the graphing calculator. So I'll start with this, natural log of 1 plus x, and then minus x, and then minus 0.1. Okay, so since we are talking about 0, and since we're talking about natural log, and we know that 1 plus x has to be greater than 0, or x has to be greater than negative 1, All I'm interested in looking as is around 0. So I'm going to go between -2 and 2 on the graphing calculator. So window, -2 to 2 with a scale of 1, and y, let's say, between -3 and 3. Let's see what happens. I may have to adjust the window later. It doesn't matter. We just looked at this problem. So, okay, here's the graph. And we want to find x. So I see it's between negative, this solution appears to be at 0, but I'm not sure. So I'll have to go from, so if we plug in 0, this is 0, 0, but -0.1 does not equal 0. So the solution cannot be 0, although this is what it shows. But I know it's wrong, because with 0, this is 0, 0, and -0.1 is not 0. So I'm going to give it a territory where the calculator has to look for the solution. So second and calc, I want the 0. And you can pass the 0 to the left and then scroll to the right, or just punch in numbers, whatever you want, but just make sure you pass the 0. Okay, so it doesn't give us a correct solution because we know it's not 0. So I'm not sure why that is. Let me look at what I entered here. Oh, okay. I put a wrong sign because it makes no sense. I knew the solution couldn't be 0. So I'm checking again. Yes, I'm fine now. Okay, so this equation appears not to have a solution near 0. Natural log of 1 plus x minus x. Am I missing anything, Derek, here? Did I copy everything correctly?
Yes, it does look like this.
Was it natural log of 1 plus x approximately x?
Yes.
And this was 0.1 or 0.01 or something else?
No, it was 0.0. It was 0.1. Sorry.
0.1. So, this is always near 0. This is always less than or equal to 0. It's never 0.
It also says, I'm sorry, that you can get your answer using interval notation. So I guess there's just some range.
Right, that's true. But if you look at this function, this equation is never 0. Unless I entered it incorrectly. Let me enter it again. So natural log, parentheses, 1 plus x, close, minus x, correct, and minus 0.1, minus 0.1. Okay. So when I do second and calc and the 0, it does not touch the x-axis. So this is always less than or equal to 0. Okay, that's fine. So let's see what we come up with. So this is true for any x value. All x. X can be any number. Of course, it cannot be just any number. It has to be greater than -1. So any number that is greater than -1. So this is the answer to the first inequality, meaning natural log 1 plus x minus x minus 0.1 is true for any value of x that is greater than -1. Okay, let's see what we get with the other one. For the other one, I have the exact same thing, but I have to put plus here. And again, second and calc, I want the 0 because I'm trying to find the when the function is 0. Okay, I see what happens here. So this has two solutions. I understand now. Okay, so I need to find, let me change the viewing window because I only want, let's say, -1 to 2. Because I want to see these two intercepts. Okay, I see what happens. So there is an x value here and an x value here. So one x intercept is between -1 and 0, and the other one from 0, between 0 and 1. So I'm going to find this one first. So second and calc, 0, between -1 and 0. So it gives me -3.383183. I don't know how many decimal digits they want. So I'm finding the other one. So second and calc and the 0, and this time is between 0 and 1. And the other one is x equals 0.51622. Okay. So now we have to put these together. So when we solve the inequality, natural log 1 plus x minus x minus 0.1 less than or equal to 0, we got the interval -1 to infinity, everything. When we solve the other one, natural log 1 plus x minus x plus 0.1 greater than or equal to 0, we obtained an interval because the graph looked like this. Between these 2 points, the function is positive. This is true only between these 2 points, this and this, which this is -0.3. I don't know how many decimal digits. How many decimal? I forget.
3.
3. So 383, comma 0.516. Now we have to intersect these two. And this will be, when we intersect them, this will be the final solution. Now, they may want, because I put the equal symbol, I don't know if they want strict inequality. So if I put the equal symbol, I have to use a bracket. If they say, you have to read it carefully when you put the answer in. If they say at least, I'm sorry, if they say at most 0.1, then you can use the bracket. If they say not more than 0.1, maybe they will want parentheses. So be careful how you enter it. But this is the final solution. This one gives us everything to the left of -1. And when we intersect this territory, let me show you one more time how to do that. So the first one is between -1 and infinity. That's the first one. The second one is between -3.83 and 0.516. If I use brackets, and that's why you see that these two have to happen at the same time. And they will happen at the same time only here. Between -3.8, -0.383 and 0.516. So that's why the intersection of these two is this one. Very good question. I love that. Very interesting. Good pick. Is this clear?
Yes.
Any questions? So graphing it, we had no choice in a sense that I didn't have to graph both on the same coordinate system. That's what I meant. But I graphed it because I could not solve the equation. This set equal to 0. I had to graph it and find with this 0 in the calculator, the 0 feature. Very good. It says that we're running out of time in a few minutes. So be on the lookout. We have like 7 minutes or so. Maybe 8, 7 something. So, and I'll create a new session. Yes, very good. Next question, please. Anything? That was a good one. Anything else? Anything you'd like to continue with, or you want me to choose?
Actually, which inequality led to the plus 0.1 and minus 0.1 for each of those separate inequalities?
You mean this one?
Yes.
Okay, let me explain. Very good question. So when we solve an inequality like this, let's say, less than or equal to 1, this really means that we are trying to find numbers whose distance from 0 is 1 or less. So this inequality changes into this. Oh, I didn't mean that. I meant 1. Since we were trying to determine the x values for which the error between the two functions, we know that they are not equal. Near 0, these two are not equal. They are approximately equal, but they are not equal. So if I want to determine the error between these two, I subtract one from the other, and that's the error. And the error, we want it to be less than 0.1. In order to change this into something I can solve, which is this, I had to write negative 0.1 less than or equal to the error, less than or equal to 0.1. It's coming from solving absolute value inequalities. Why I have to put it in absolute value is because the error could be positive or negative. So that's why the error has to be an absolute value, which reduces to an absolute value inequality, which reduces to this compound inequality. Of course, with the equal symbols, because I put the equal symbol here. So that's where this is coming from. From here. Once I write this, then I have to follow up with this. We've seen this in the epsilon delta definition, if you remember. Again, there. Was this the question? Did I answer your question?
I think so. I was also asking about just the step below that when you transition into two separate equations.
Oh, yes. So I cannot solve the inequality before I solve the equation. So it's not that I'm changing the inequality into an equation, but I don't know how to solve this before I change it into an equation in this particular case because I have to use the calculator.
Okay.
So very good question. Excellent. So let me explain one thing. Very good question. So if you ask me to solve the inequality, the absolute value of 2x minus 3 less than or equal to 2, let's say, then I will write negative 2 less than or equal to 2x minus 3 less than or equal to 2. I don't have to take this on the side and solve for x. There is no need because I can do this by hand. So I'm just going to add 3 to all three sides, and I get 1 less than or equal to 2x less than or equal to 5, and divide by 2, and I get 1/2 less than or equal to x less than or equal to 5/2, and it's done. So it's 1/2 5/2. But here, I can't solve this equation without a calculator. If I could have, I would have not used the equation at all. So I had to create this equation, solve it with a calculator, and then solve the inequality. Then I had to create this equation, solve it with the calculator, as we did, find these two solutions, and then solve the inequality. And then have to intersect these two solutions. So here, I didn't have to intersect. I didn't have to solve them separately. So let me show you, if you solve them separately, here's what happens, which we don't recommend in this case. It's too simple. So let's say I have 2x minus 3 less than or equal to 2, which means 2x less than or equal to 5, which means x less than or equal to 5 halves. So keep this in mind. Now the other one, negative 2 less than or 2x minus 3 greater than negative 2, 2x minus 3 greater than or equal to negative 2. I move 3. I get 2x less than or equal to greater than or equal to 1. So now, because I separated them, which in this case should not be the case, now I have to intersect them. So this one says less than or equal to 5 halves. Let's say here's 5 halves. Less than or equal to 5 halves is this. The other one says greater than or equal to 1 half. Well, 1 half is here to infinity. And now I finally get the common territory of purple and blue, and I get this, which I already have gotten. There is no need for this, to separate them. Here with this problem, I have no choice. I'm not capable of solving this by hand. And I'm not capable of solving this by hand to solve them together, like I did here. I don't have that capability. I have to find the solutions with the graphing calculator. So that's why I had to separate and then eventually intersect like we did here. So we have to intersect these two solutions. Greater than or equal to 1 half and less than or equal to 5 halves. That's how I get this, which I would have normally gotten in a blink anyway. Very good question. Thank you for that. I think it's possible that this question is on many people's minds. So, very good. Who asked this question? Very good question. Was it Reese?
Yes.
Thank you. Very good. Okay, thank you. Next question. Okay, less than 1 minute, so let's stop. So I'll send you another